Limit as x goes to 0 of the sine of x minus the tangent of x over the sine squared of x. The first thing we're going to do is plug a 0 in for each of the x's. That will give us a sine of 0 minus the tangent of 0 divided by the sine of 0 quantity squared. The sine of 0 is 0. The tangent of 0 is the sine of 0, which is 0, over the cosine of 0, which is 1, and 0 over 1 is a 0. So we have 0 minus 0 over the sine of 0 is 0 squared. 0 minus 0 is 0. 0 squared is also 0. So we have the 0 over 0 indeterminate form. This is resulting from trig functions. In the denominator, we have one of the trig functions squared, and therefore we have a Pythagorean trig identity that we may be able to use here. We know that the sine squared of x plus the cosine squared of x equals to 1. So the sine squared of x is equal to 1 minus cosine squared of x, which is factorable. But if we're going to make use of that, we have to be able to factor the numerator as well. And right now the numerator is not going to factor just yet. But if we rewrite tangent as sine over cosine, which I'm going to do now, limit as x goes to 0 of sine x minus sine x over cosine x. We have a common factor of sine x in those two terms. Before I actually factor them, I'm going to get a common denominator between them and combine them together. That'll just make things easier to actually factor. So it looks like the common denominator is going to be cosine of x. I will multiply the sine of x by a cosine of x over a cosine of x form of 1, so that I put it over the common denominator as the other term, and then I can actually subtract those and combine those terms together. So I will do that. Now, because this is going to produce a fraction in the numerator, I am going to need to reciprocate the denominator and multiply. But it looks like I will have sine x cosine x over cosine x for the first fraction minus sine x over cosine x for the second fraction. They're over a common denominator, and therefore can combine through subtraction, and that will become sine x cosine x minus sine x, all of that over cosine x, and then the overall denominator of sine squared of x. We're going to reciprocate that and multiply it. So I need to make it a fraction. I put it over 1 so that it is a fraction to reciprocate and multiply, and that's going to be our next step here. So we have limit as x goes to 0 of the sine of x cosine of x minus sine of x divided by cosine of x. And this is going to be multiplied by 1 over sine squared of x. And then multiplying these together gives me a numerator, sine of x cosine of x minus sine of x times 1, which doesn't change it. And in the denominator, we have sine squared of x cosine of x. Now, we have a Pythagorean trig identity that we can make use of. Sine squared of x can be replaced with 1 minus cosine squared of x, which is factorable, and we're going to do that. There is a common factor of sine x in the numerator, and that can factor out. But do not cancel that with the sine squared of x in the denominator, or it will not allow us to do the difference of squares factoring from the Pythagorean identity. So I'm just going to leave the numerator alone right now, even though it will factor. And in the denominator, I'm going to rewrite sine squared of x as 1 minus cosine squared of x times cosine of x. And now we can factor the numerator and denominator. In the numerator, we have a common factor of sine of x, leaving us with a cosine of x minus 1. in the denominator, we have a difference of squares, which will factor into a 1 plus cosine of x and a 1 minus cosine of x times the cosine of x. Now we have 0 over 0, and cosine of 0 is a 1, and we're getting a 0 because of the cosine of x minus 1 in the numerator and 1 minus cosine of x in the denominator, and we can get those to cancel. They're opposite signs right now, so the next thing I'm going to need to do is factor a negative out. So that's what I'll do. I'll factor it out of the numerator expression, which will change the 1 to be positive and the cosine of x to be negative, and I will have 1 minus cosine of x. And in the denominator, I have 1 plus cosine of x and 1 minus cosine of x and cosine of x, all multiplying each other. The 1 minus cosine of x can cancel now, which should remove the 0 over 0 indeterminate form. And I have limit as x goes to 0 of the negative of sine x divided by 1 plus cosine x times cosine x. And what we can do now is plug in a 0 for the remaining x's. Since we are no longer the 0 over 0 indeterminate form, I'm getting the negative sine of 0 over 1 plus the cosine of 0 times the cosine of 0. Sine of 0 is a 0, so I have negative 0 over. Cosine of 0 is a 1, so I have 1 plus 1 times a 1. The negative of 0 is a 0. 1 plus 1 is a 2 times 1. 2 times 1 is a 2. I have 0 over 2. 0 over any non-zero number is equal to 0.